All right, so this week, one of the big things that we're going to talk a lot about is multiplying polynomials. And so before we get into what we do when we multiply these really long, crazy things with a lot of exponents together, is that we need to understand these terminologies. All right, so a monomial only has one term. Okay, a binomial has two terms. So a monomial is something like x or 4x or y. Those are all examples of monomials. A binomial might be something like this, x plus 3. Or y minus 2. Those are examples of binomials. So if monomial is 1, binomial is 2, trinomial is 3. And that might look like something like this, x squared plus x minus 2. Okay? So knowing what these are, we're going to look at how we multiply them. And these are two things I'm going to tell you that we're going to do for every example that we have. All right, so looking at the multiplying monomials examples, first thing we're going to do is multiply the coefficients. So we multiply the coefficients, we add the exponents. And this is something that you guys have actually been doing since last week. You just didn't really notice or realize it. All right, so looking at example number 1, first thing we do is multiply our coefficients. So 3 times 4 is 12. And then we add the exponents. And a lot of people are like, exponents, where are they? Well, if you don't see them, put them in there. Doom, doom. All right, so I remember from last week that if they're not written in there, then they've got to be there somewhere. All right, so we have 1 plus 1 gives me x squared. Okay, looking at example 2, multiply your coefficients. So 5 times 10 is 50, and then we add our exponents. X to the 4, 5, 6, 7th. Okay, last but not least, first thing I notice about this problem is that it's a little longer, but there should be an exponent there. Okay, so I'm going to go ahead and multiply my coefficients. So 4 times 5 is 20, and I'm going to add the exponents. So we have a y this time, so 2 plus 3. And I also have an x, so 1 plus 4, x to the 5th. All right, so that one right there should be a little bit of a review for you. Because now moving on, how we multiply binomials and trinomials is actually exactly the same way. One's just a little bit longer than the other. So there are two different ways that we can actually solve these problems. The first one is distribute from one parenthesis I think I spelled that right, to the other, or we can use the box method. Okay, we're still going to multiply, and then we are going to combine like terms. So I'm going to switch up my colors, and I'm going to show you what I mean by these two examples. I'm not going to lie to you. The box method is my preference of choice. My preferential, I don't know, I haven't had coffee yet this morning. My choice when I solve these problems. But I'm going to show you both ways because one might be easier for you to understand than the other. So the first one, to distribute from one set of parentheses to the other means I'm going to rewrite this so you can see it. 2x plus 2 and then 6x plus 1. All right, so when I say distribute, that means I'm going to take this 2x and I'm going to, well, before I do that, I'm going to write in my exponents here so I don't get confused. And now I'm going to distribute this 2x to everything in this second set of parentheses. So I'm going to go 2x times 6x, which is, thank you, which is the same thing. So 2 times 6 is 12, but we add the exponent, so that's exactly what we just did. So x squared, and then I'm going to distribute that to the 1. So I know that that's plus 2x. Okay, so that was distributing the 2x to everything over there. I still have to distribute the 2. So now I'm going to go 2 times 6x, which is a plus 12x, and 2 times 1, which is 2. If we did this right, our like terms should be right here in the middle. Okay, so our answer is 12x squared plus 2x plus 12x, 14x plus 2. Okay, now the box method, again, like I said, this is my way, my choice. So what we're going to do, and you guys actually have already done this in biology, we're going to go ahead and draw, if there's 2 and 2, we're going to draw a 2 by 2 box. And we're going to put one on the outside and one on the top. Well, both of them will be on the outside, one on the side, one on the top. So it doesn't matter where you put them. Okay, and now we multiply the top and the side to get what's inside the box. So 2 times 6 is 12, x times x is x squared, 2x times a positive 1 is a positive 2x, 6x times 2 is a positive 12x, and positive 2 times positive 1 is a positive 2. The reason I like this is because it's very easy to see our like terms, because if we look, our like terms are diagonals of each other. So when we have to add together our like terms, we start here, so we have 12x squared, add those two, 14x plus 2. Okay. Looking at example number 2, same idea. So I'm going to show you both ways. 4x, oh, sorry. Go ahead and write my exponents in there. If there's none there, it's always the understood 1. So 4x times 2x, 8x squared. 4x times 6 plus 24x. And then negative 3 times 2x minus 3x, or I'm sorry, minus 6x. Negative 3 times negative 6 is negative 18. So when we combine like terms, we get 8x squared plus, what is that, 18? I don't know. I don't know. I'm pretty sure it's 18. 24 minus 6. Yeah, it's 18. Plus 18x minus 18. Okay. And box, we're still going to do a 2 by 2 because these are binomials. Okay. So 4x minus 3. And notice I did keep the minus there, so that way I remember that that's a negative 3 when I multiply. 2x plus 6 remember your exponents. Okay. And then multiply, so 4 times 2 is 8. Add your exponents, x squared, 24x, negative 6x, negative 18. So when you combine your like terms, you get an 8x squared plus 18x minus 18. Okay. All right. Now I'm going to leave example number 3 for you guys to do, and I want you to either show me your notes or check in with me to see if you got it correct. But I do want to show you very quickly how we're going to do a problem like this where we have a binomial times a trinomial. Okay, so we have 2 terms times 3 terms. Okay, so the first thing I'm going to do is I'm going to go in and I'm going to put my exponents where they should be because I noticed that they're actually not listed. Okay, and so now, and I'm going to put a coefficient here, understood 1, that's going to make our lives a little bit easier. Okay, so sorry about that. And so one of the ways that people do this is, yes, they do distribute from one parenthesis to the next. It just makes it very long, and a lot of people do tend to mess up when they combine like terms. So if you're doing something like this, I highly recommend that you do the box method. So I do want to show you the box method, and then I will show you what it looks like to just distribute all the way through. And so first, the box, because I think it's easier. We're going to do a 3 by 2. Okay, so it doesn't really matter how you set this up. I like to have 3 columns and 2 rows. I just think it's going to make it a little bit easier for us, but that's just me. That's a really big middle box. Oops. So I'm going to do k squared minus 2k plus 7. And then we have 7k negative 3. Okay, so I'm still going to go ahead put, oh, that should be a 1. I'm dumb. 1, 1, okay. And then we're still going to do what we did before. We're going to focus on multiplying the top by 7k. Okay, so 7 times 1 is 7, and we add the exponents, so 1 plus 2 is 3. 7 times negative 2 is negative 14, k1, k1, k2. 7 times 7 is a positive 49, k. Now we're going to move to the bottom row. Negative 3 times k squared, negative 3 k squared. Negative 3 times negative 2 is a positive 6, k minus 21. And if you notice, our like terms are still diagonal. Okay? So when we add all of them together, we get 7k cubed minus 17k squared. 49 and 6 is a positive 55k minus 21. Okay, so distributing, I'm going to rewrite it out so you can see everything. 7k minus 3 times k squared minus 2k plus 7 with exponent, coefficient, exponent, just so we can remember to add our exponents together. So first one, we'll distribute 7k times 1k squared, which is 7k cubed, Sorry about that again. 7 times negative 2, negative 14k squared, because we add the 1s. And 7 times 7 is a positive 49k. All right, and so now we're going to distribute the negative 3. So negative 3 times k squared, and I'm going to literally just write it right underneath it. So we have a negative 3k squared. Negative 3 times negative 2 is a positive 6k. Negative 3 times positive 7 is a negative 21. So when we combine like terms, we add them together going down. So we have 7k cubed minus 17k squared plus 55k minus 21. Okay, now I want you to give number 5. I want you to give that one a shot. Let me know how you do. We'll go over it if you have any questions.